In this video, we're going to solve some questions related to vector and scalar quantities. If you haven't watched the previous video, this is a continuation of our discussion on scalar and vector quantities. So in this video, we're going to solve questions related to vector and scalar quantities. So let's get into it. So I'm going to start with questions from the UTME past question. And if you want to get these questions, you can just download the application, install it, and you go to question search, you type scalar and vector, and you get questions related to that topic. So let's take them one after the other. So we're going to start with question 4 from the year 2008. So the question says, which of the following is not a vector quantity? So let's look at it carefully. We have altitude, acceleration, displacement, and weight. So altitude has to do with distance, distance in the upward direction. Then we have, but then it just tells you how high something is from the ground, but does not necessarily tell you the line of action. So acceleration obviously is a vector quantity because to define acceleration, you need to define the direction along which that motion is happening. Then displacement is distance with a direction, so that's a vector quantity. Weight is force basically, is in the same family as force, and force is a vector quantity. So altitude is not a vector quantity because it is like a distance in the upward the is like distance above a particular ground level, and it has no direction in particular. So altitude is not a vector quantity. So let's take a look at another example. So that's question 12 from the year 2003. So the figure above shows two velocities, v1 and v2. Which of the following diagrams correctly represents the vector difference? So here we have two velocities. So this is v1, right? And this is v2. And now we are told to look for w, which is v1 minus v2. So based on what we discussed earlier, to combine two or more vectors, you use geometry. So let's look at how, if we were to do the addition, how do you think we would have gone about it? To add two vectors, you take the first one, which is v1, then you continue from the head of the first one. So this is v1, right? Then you continue from the head of the first one and draw the second one, which is v2. So this vector would be the combined vector. So if you were to look for the addition, right? If you were to look for the addition, this would have been the answer. But then what we are asked to look for is the difference. So in this case, you have to look for the negation of v1. So what's the negation of v2 rather? What's the negation of v? The negation of v2 is like v2, but in the opposite direction. So it's more or less like you having, instead of you going upward, you go downward. So it's like v2 in the opposite direction. So which is something like this. This is minus v2, right? So how then do you combine this minus v2 with v1? Because you can break this down as, you can break this as v1 plus minus v2. This is how you can break it down. So if you look at it carefully, you'll see that since we now have a representation for minus v2, to combine the two, you just simply take this v1, right? This v1. Then you go in the opposite direction, which is this. Right? So this is the minus v2. Then the resultant will be this. So w will be something like this. So this is basically how you can conceptualize how to calculate the difference between two vectors. So let's check out the option that closely resembles what we've just drawn out. So if you look at all the options, you'll see that the one that closely resembles what we have is option C. Is option C. Okay, so let's take a look at another question. So this time around, we're going to look at question 33 from the year 2016. So the question states that which of the following quantities listed above are vectors? So let's start with the first first one, electrical potential. Electrical potential is a scalar quantity. It has nothing to do with direction. Then torque is, you can see torque is force times distance. So since torque is force times distance, you can imagine torque to be a force multiplied to a distance. So definitely it has a direction, because it's more or less like you taking a force, which is a vector quantity, and you multiplying with the distance, with the perpendicular distance. So that is torque, and that represents that's a vector quantity. Then kinetic energy is not, because anything energy is not any form of energy is a scalar quantity. We've talked about that. Then momentum is velocity times mass, right? Mass times velocity, that's momentum. So since you have velocity multiplied to a mass, there's a sense of direction. And because there's a sense of direction, it is a vector quantity. So we can say that II and IV, which is torque and momentum, they are vector quantities. So that makes option D to be the right option. So let's look at another question. Let's take a look at question number 9 from the year 2002. So the question goes as follows. Two force, each of 10 Newton, act on a body, one towards the north and the other towards the east. So let's imagine this point represent the body, right? Two force, each of them is 10 Newton. There are two forces, each of 10 Newton act on a body, one towards the north. So one of them is towards the north and it's 10 Newton, right? And the other is towards the east and is also 10 Newton. Now the question is, the magnitude and direction of the resultant force are. So the question is now asking, what's the resultant force? We need to get the magnitude and direction of the resultant force. So how do we go about that? So we can use various approaches, but one strategy we can just use is to use the triangle method, or just, yeah, we can use the triangle method where we just look at the diagonal, or we can use the parallelogram law of vector, whatever method you wish. But let's use this parallelogram law where you try to enclose the shape and the diagonal becomes the resultant force. So you in the case of parallelogram law of vector, you enclose the shape and you make the diagonal becomes the resultant force. But in this case, the parallelogram now has a shape of a rectangle. Parallelogram is a general representation of any shape that can be bent, that can have a side that is tilted. But a rectangle can be seen as a subset of a parallelogram. So what that means is, in this particular case, we have a rectangle now, or maybe a square, depending on if we can tell all the four sides are the same. So let's take a look how to solve this. So this is the resultant force. And how do we go about solving this? This side, we have the same side as this side will be equal to this. So this is also 10 Newton, right? And this is also the same thing as this. But let's just work with this information. This is 90 degree. This is 10 Newton, 10 Newton. So what do you think would be the value of the diagonal? You can apply Pythagoras theorem and that's very straightforward. You just say r squared, which is the square of the hypotenuse, is equal to the square of the sum of the squares of the other two sides. So that will give you 100 plus 100, and that's 200. Then r is 200 squares of 200, which is equivalent to the square root of 100 times 2, which you can write as the square root of 100 times the square root of 2, that's 10 root 2 Newton. So this is the magnitude of the resultant um, force. So what about the direction? To get a direction, what you expect to get is what angle are we dealing with here, or what angle are we dealing with here. So let's try to get any of the angles. So let's focus on this angle here, this theta. So if we get a theta, then we can interpret the direction. So theta can be obtained in various ways. So, but since we have the opposite and the adjacent, we can just use the tangent. So tan theta is opposite, which is 10, over adjacent, which is 10 as well. So this will give 1. So if tan theta is equal to 1, then theta is at tan 1, and at tan 1 we give 45 degrees. So this means theta is 45 degrees. So now what can we say about direction? We can say that the direction is 45 degree, because if this is 45 degree, this other side is 45 degree. So we can say it's 45 degree east, so towards the east, because this is the eastward direction, right? So first, the magnitude is 10 root 2 Newton. Second, the direction is 45 degrees northeast, right? So let's look at the option that closely resembles what we have. So the correct option here is option D. So let's look at another question. Let's take a look at question number 12 from the year 2000. So the question goes as follows: a stream is flowing at 0.75 meter per second, and a boat heading perpendicular for the stream landed at the opposite bank at an angle 30 degree. Calculate the velocity of the boat. Okay, so let's interpret the question. So let's say this is the stream, this is the stream, and the stream is flowing at a particular speed of 0.75 meter per second. So we were not told the exact direction, whether it's heading to the left, so that's eastward or westward, so you can pick any direction of your choice. So what this means is the direction of the stream, the water in that particular let's say river, for instance, or stream, is flowing, the speed at which the water at which the stream is flowing is 0.75 meter per second, right? Now there's a boat here. This boat wants to cross to the other side. So let's say you have this boat. This boat is aiming at crossing to the opposite side of the stream. But because of the moving water, the boat ended up getting to the opposite side at an angle of 30 degrees. 30 degrees to the horizontal, right? So what this means is instead of, let's say, instead of the boat getting exactly getting to the exact opposite point, it was moved slightly in such a way that it ended up making an angle 30 degree to the horizontal here. Now the question is now saying we should calculate the velocity that the boat must have been moving to make it end up landing here, right? So just like saying if this boat moved, because the boat must have moved at a particular speed to reach here. If the boat did not, if the speed of the boat is 0, it means it will just flow with the stream and it will never get to this point. To just flow along with the stream. But because of the speed of the boat, the vertical speed of the boat. The boat was able to get to the opposite side, but because of the drift of the stream, it didn't get to the exact opposite. It was moved by some angle, right? So the question is, what must be the speed of this boat that would have made it to get to this point? So that is what the question it's what the question is all about. So let's break it down this way. So here you have the starting point of the boat. Then here you have the end point, and this is the angle it made with the horizontal part, right? And now the question is, what must be the speed that this boat must have launched with? So this speed is what we don't know. Let's call it v. But what we know is we know the speed of the stream. The speed of the stream is horizontal, right? And the speed of the stream is 0.75 meter per second. So what we are now looking for is this v. So we know this angle, we know the points where the speed of the stream, but we don't know the velocity of the boat. So what's the velocity? So let's calculate that. So this is how we can calculate the velocity. This 30-degree is equivalent, we can break it down this way. This velocity is also 0.75 meter per second. This can also be taken to be the velocity, right? And now that we know the angle, we know the adjacent, but we don't know the opposite. So what formula can we use to get this opposite? You know the angle, you know adjacent, you don't know opposite. So what mathematical formula connects angle, opposite, and adjacent? That is tan. So tan 30, tan of the angle is opposite, which is v, over adjacent, which is 0.75. So the velocity would therefore be 0.75 times tan 30, and that will give you 0.75 times 0.577, and then if you multiply these two, you're going to get 0.433. So this is the velocity with which the boat must launch vertically in order to get to this point that it eventually got to. So this is how you basically calculate the speed of the boat. Let's solve question number 12 from the year 2000. So the question goes as follows. A stream is flowing at 0.75 meter per second and a boat heading perpendicular for the stream landed at the opposite bank at an angle 30-degree. Calculate the velocity of the boat. So this is what we're talking about here. Here you have a stream, and the stream is moving. That's the liquid, the water in the stream. They are moving at 0.75 meter per second. And here is a boat that wants to cross to the other side. But instead of it getting to the exact opposite end, it drifted a bit and landed a little bit far off, but at the opposite end, but not exactly at the opposite end. And it formed an angle 30-degree to the horizontal here. So the question is, what's the velocity of the speed? That is, what's the velocity of the boat as the boat traveled along the stream? At what speed or velocity rather did the boat travel? So let's break it down this way. So here's the boat, right? Then there's the path taken by the boat, and this is the angle formed, angle 30-degree here, and the speed of the stream is 0.75 meter per second. And the question is, what's the speed or the velocity of the boat as it traveled through the stream? So this is the velocity that the boat will actually travel at. But if you are asked to look for the velocity that the boat will launch with, that is the launch velocity of the boat, then that would have been this horizontal speed. But then we are asked to look for the actual velocity of the boat as it traveled through the stream. So this is the actual velocity that the boat will travel at. So now we need to look for the value of v. So how do we get value of v? So you can try to complete this. So this looks like a rectangle triangle. So here is the hypotenuse, and this side is the adjacent to this angle. So what formula we want to use here? Since we know the adjacent and we know the hypotenuse, cos is the right thing to do, cosine. So cos 30 is equal to the adjacent 0.75 divided by the hypotenuse. So hypotenuse is 0.75 divided by the cos 30, right? Then if you do this mathematics, you're going to get 0.866 meter per second. So this is the velocity at which the boat will travel at. So let's take a look at another example. So here's a question. The question is from the year 2000, question number 2. A handbag containing some load weighing 162 Newton is carried by 2 students, each holding the handle of the bag next to him. If each handle is pulled 60 degrees to the vertical, find the force on each student's arm. So let's break it down this way. So here you have a bag. This bag weighs 162 Newton, and you have 2 students holding on to the bag, one on this side. This is one person is holding it on the right hand side, another person is holding it on the left hand side, and they are holding it at an angle 60 to the vertical. So what that means is angle 60 degree here, angle 60 degree here, right? And the question is if we should find the force on each arm. So the question is what will be the force here, F1 and F2. So since both of them are being held at the same angle, we expect that both forces will be the same. So that's why you don't need to look for each of them separately. We end up having the same value since they are holding on to the bag at the same angle. But let's calculate one of the forces. So how do we compute for this? So let's break it down this way. So here you have the representation. So this is 60 degrees, 60 degrees, and here you have 162 Newton. And since the whole thing is balanced, what that means is the combined forces here, this F1 plus F2, balances this. So what this means is the resultant force, the resultant force, which is going to be this, balances the weight of the object. So which means we can say that the resultant force is the same as the weight of the object but in the opposite direction. So what then will be the value of F1 and F2 that will balance this 162 Newton? So what we need to do to determine the value of F1 and F2 is to resolve F1 and F2 to form to resolve it to get the the vertical component, because once you have the vertical component it will be equivalent to the downward force on the bag. So what that means is this: if I have these two forces this way, and here you have the weight which happens to be 162 Newton. If I resolve this, if I get the F1 along the y-axis and I have the F2 along the y-axis, the components, these two will be equal to 162 Newton, because this resultant force along the vertical axis will balance the weight of the bar. So how do we get this F1y and F2y? So since this is 60 degrees and this is 60 degrees, to get this component, since this component is adjacent to this 60 degrees, it means F1y will be whatever you have here, which is F1 times cos 60 degrees. F2y will also be the same, so which will be F2 cos 60 degrees. Since both students are holding on with the same force, right? Since they're holding on to the same force, it means we can say F1 is equal to F2. So which implies that we can just say these two, this F1y plus F2y can be written as F2 twice of this. So we can simply say 2F1y is equal to 162 Newton. So what is F1y? That's 2F1 cos 60 equals 162. Then we have F1 is equal to 162 over 2 cos 60. So what's cos 60? That's 0.5. So 0.5 times. So this will give 162 divided by 2 times 0.5. And that makes this to be 162 Newton. So what this means is the force, the F1, which is equal to F2, will be equal to 162 Newton. They will have to be holding on with a force of 162 Newton, which makes option B the correct option. We're going to take our last question from SSC past question, and that's question number 11BI from the year 2011, and that's theory question, right? So let's interpret the question. The question says that three vectors, so let's name them V1. The first vector is the magnitude is 3 meters per second, and the direction is north 45 degrees west. For the second vector, we have 12 meters per second, and the direction is west, that's due west. Then the third vector is 5 meters per second, and the direction is south, and they all act on a point. So the question is, sketch a diagram, a vector diagram to represent the given information. So let's say this is the point. So what is the representation of the first one? 3 meters per second, and the direction is north. So let's say this is coordinates. This is north, this is west, this is east, and this is south. So if you say 45-degree west, so you are referring to this direction. So if you go from the north towards the west, then you have 45 degrees. So that is what you have here, and that's the magnitude is 3 meters per second. Then for the second vector, we have 12 meters per second west. So that's due west. So 12 is going to be as long as this, much longer, but we don't have enough space. So this is 12 meters per second, and the third is south, and that's 5 meters per second south. So that would be something like this, and that's 5 meters per second. So we've sketched the three vectors acting on a single point. So let's move on to the next question. The next question states that we should calculate the resultant vector. So what's the resultant of all the vectors? So let's solve for the resultant vector. So let's solve for the resultant vector. So we discussed earlier that to look for the resultant vector of three or more vectors, we need to resolve each of the vectors into their various components. So let's approach it this way. So we're going to specify the vector here. So this is v1. Then we're going to this is the angle to the horizontal. The angle to the horizontal. Then we're going to compute the horizontal component. Horizontal component. Then we're going to get the vertical component. Vertical component. Then that's it. So let's take them one after the other. For the first vector, what is the magnitude? For the first vector, the magnitude is 3, right? Then what about the angle to the horizontal? So this is how you think about the angle to the horizontal. If you look at how the angle from here to this point, right? So that's 45 degrees plus 90. So that will give 135 degrees. So let's look at the second one, V2. The magnitude is 12. Then the angle to the horizontal starting from this point is from here down to this point. That's 180 degrees. Then for the V3, what do we have as the magnitude? That's 5. Then what about the angle to the horizontal? That angle is from this point to this very point. That's 90 plus 90 plus 90. And that will give 270 degrees. So now what's the horizontal component? The horizontal component is always going to be the value which is the magnitude, which is 3 times cos the angle, cos 135, which is equal to minus 2.1213. So let's look for the vertical component. That's 3 sine 135, and that's equal to 2.1213. So let's move on to the second vector. To get the horizontal component, you just take this 12, multiply it by cos of the angle, which is angle 180, and that will be and that's equal to minus 12. Then the vertical component will be 12 sine 180, which is equal to 0. For the third vector, you will get the horizontal component by taking the magnitude, which is 5, then multiply by cos of the angle, which is 270, and that will give 0. Then for the vertical component, you take the magnitude times the sine of the angle, and that will give minus 5. Okay, so now that we've gotten all the vertical and horizontal components, the next thing you want to do is to take the sum of all the horizontal components. So let's call this Vx, and the vertical, let's call it Vy. So what's the sum of minus 2.1213? You add it with minus 12 and 0. So that will give us minus 14.1213. If you add up this vertical component, you're going to get minus 2.8787. So let's represent this resultant horizontal component and vertical component. So if you have this as your origin, what is minus 14? So this is the y-axis and this is the x-axis, right? This is y, this is x. So what's minus 14 along the x-axis. So you're talking about this region, right? So this is minus, so let's say we have this direction. So this is minus 14.1213. Then for the vertical component is on the negative part of the axis. So that's minus 2.8787. So what do you think will be the resultant vector? So the result vector is going to be along this direction. It's going to be along this direction. But then we are going to, so the direction will be along the side. Then the magnitude will be the length. So this will be minus 2.8787. So let's say this is VR, the resultant vector. So VR would simply be the square root of 14.1213 squared minus 14.1213 squared, then plus minus 2.8787, right, squared. Then if you do this math, the results will be, so this will give 14.4 meter per second. But what about the direction? So how do we get the direction? So you can get the direction as follows. So the first thing you want to do is to get this inner angle, which is theta. Then you add it to this whole angle, which is 180. So let's get this inner angle. So to get the inner angle, you just know that this is opposite and this is adjacent. So tan theta is opposite, which is minus 2.8787 divided by the adjacent minus 14.1213. So that makes tan theta to be equal to 0.203 per 9. So what will be the angle theta itself? So to calculate the angle theta, this is what we'll do. Angle theta will be the arctan of 0.2039, and that will give 11.5 degrees. So in summary, we can say that the resultant vector is, the magnitude is 14.4 meter per second, and the direction is 11.5 degrees plus 180, which will give 191.5 degrees to the horizontal. So to the horizontal axis. But then you can also define the direction in terms of north or north, west, or what have you. So if I want to define in terms of southwest, I can just subtract the 90 degree, the theta from 90 degree and all of that. But it all depends on the format that you are asked to represent it. But this is the direction in terms of the horizontal axis. So this is how you determine the resultant vector of three or more vectors. So this brings us to the end of this particular video.